I'm thinking of a theme tune for my channel. Maybe that's very good, or maybe it's just garbage, but who cares? Let's get on with the science. So what we're going to be looking at in this section is the noble gases. Okay, now this is part of group 8. Let me just bring up my periodic table. Here is group 8, or commonly called group 0, but here it is: helium, neon, argon, krypton, xenon, and I believe the last one is radon. So anyway, let's look at the discovery of noble gases. Now what you got to remember, guys and girls, is noble gases are extremely unreactive. Okay, they are extremely unreactive, and I'm going to get the periodic table up again. Now if you look at group 0, aka group 8, what you're going to know from the group patterns that we've already discussed is that all of group 8 or all of group 0, same thing. I'm just going to call it group 8, guys, because group 0 is just stupid. Now all of group 8 have a full outer electron shell. So because they have a full outer electron shell, they will not react with anything. So because they are so unreactive, it was quite difficult to detect them in the first place. And this is where we have our first geezer. Our first geezer is this guy, Lord Rayleigh. Now he did this kind of experiment and this idea, and he made this observation, so we say. What he did was he took pure nitrogen, right? So this is pure nitrogen made from chemical reactions. Okay, so this is made during chemical reactions, right? So this is made during chemical reactions, and he measured its density, right? Now guys, the numbers are made up completely, okay, but I'm just want to illustrate the point. So he measured the density of pure nitrogen, and then he measured the density of nitrogen within the air, and what he found was that the nitrogen within the air has a higher density than that when you make pure nitrogen from chemical reactions. And that was kind of left to the side for a while, and it was just like an observation, and it was interesting, but there's no explanation. In comes this guy here, the second dude. This guy name was William Ramsay, and here's my picture of William Ramsay. Very flattering. I'm sure he'd be happy. So William Ramsay had an idea. He was like, this one is denser, not because nitrogen is denser, but because there must be something that we can't find, something present in this that we just can't see and we can't detect. And so through a series of experiments, he ended up finding out that actually the nitrogen from this air does contain other elements, and that's how he discovered argon. He also then went on to discover helium, xenon, and krypton. So this guy was a bit of a genius, krypton. And so that's how he discovered. So he separated out everything and ended up finding out that the extra density can be accounted for by these other very unreactive elements. So what a geezer, what a geezer. Hats off to him. So now we're going to look at some of the properties of these noble gases. Now with the noble gases, like we said, they have a full outer shell. Okay, so because of that, they are unreactive, and this allows us to use it for some interesting things. Now I'm going to pick the obvious ones first, so let's go to our periodic table. The obvious one are neon and helium. Okay, everyone knows what helium is used for and what neon is used for. So here's helium. Excuse me. Helium is used for zeppelins. Okay, zeppelins, and this is because zeppelins have those are those kind of ships that fly in the sky. You know what I'm talking about, guys. Here's my zeppelin, and there's kind of like a basket thing here, and it's a big kind of air balloon. Now zeppelins use helium because helium is less dense than air. and so because it's less dense than air, that means it's gonna rise and float and go upwards, and so that's why they use. Now the other reason why is because it's unreactive, so it's not going to cause any reactions, explosions, etc. Now why do I say this? Because back in Nazi Germany, when the Americans did get on with the Germans at the time, there was the Hindenburg disaster, where the Germans did not use helium, they used hydrogen for their zeppelins. And what happened? There was lightning. The lightning struck the hydrogen gas, and hydrogen gas is very explosive. Bam! Loads of people died in it. So why do we use helium? Because number one, it's less dense than air. Hydrogen is also less dense than air. However, helium is not reactive because it's got a full outer shell. Therefore, there's not going to be any explosion. Hydrogen is very unreactive. Oh, sorry, if hydrogen is very reactive, it's going to cause an explosion. Brilliant. The next one everyone's familiar with is neon. Okay, let's look at neon. Neon is used for neon lights. Done. Then what we've got is argon. Argon is used for welding. Okay, and basically what they do is, if you imagine, here's my metal, right, and what they're going to do is they're going to spray over some argon. Now I don't know why, but argon. So they're going to put over some argon over this metal while the welding's going on. And the reason why they're going to make sure the argon layer is here on top of the metal is so that the metal does not react with the oxygen in the air. Okay, so that's that one done. Also, xenon is also used nowadays for lights. Okay, you have those xenon lights, and they are to make sure that the lights last long, because they are, once again, xenon is unreactive. So that's noble gases done. I'm going to stop the video.